here with Split Culture, my company. I should say Split Culture LLC, my company. And we promote research at the speed of life. Just to give you a little bit of background, this is our team. I'm the Chief Executive Officer. I'm a patent inventor with chemical engineering and entrepreneurship student, and I have been for the last 3.5 years. Our Chief Operating Officer is Bob Miller. He's been in 7 different startups, including the food delivery app Waiter. If any of you are familiar with that, it's very popular in the Deep South. And then Dr. Adam Melvin is our Chief Science Officer, as well as my personal mentor in my lab. And he is Assistant Professor in the Chemical Engineering Department, and he has far too many accolades for me to fit here. Just to give you a little bit of background about what this product is for, it's for something called co-culturing. So we're going to bring it all the way back to high school biology and talk about cells. So co-culturing is growing any type of cell near each other. The type of work that I do is focused on breast cancer research, incredibly relevant to today. So those are cancer cells, and these are healthy human body cells. And what we do and what this device enables is for us to study better than ever the communication between these two types of cells, using primarily small molecules, including some physical cues, but we're mostly focused on the chemical perspective. So this helps develop the latest therapies and potentially target new studies as well. So other applications for co-culture, and this kind of gets into what we've been doing here today. If, for example, you enjoyed any of the brews last night or any at your local craft brewery, some of those unique beer flavors are made by culturing different types of yeast together. That's a co-culturing application, right? If after that you're not feeling super well and you hop into an Uber and we have some of our new biofuels that are blended in with our gasoline, those different types of algae are co-cultured together for optimization of that particular fuel source. And then let's say you brought home not just a hangover from the bar, but some type of virus. All of the new drugs that make it to the market much quicker than previously because of co-culturing techniques that cut down the drug screening time, which is, again, a multi-billion-dollar industry. So this exponentially increases our total addressable market, aside from just human mammalian cell culture. So how this is done now, I just need you to understand briefly, it uses these small plastic plates and then plastic inserts that fit into those. Those are made of a polycarbonate material. So essentially cells are placed in the first plate and then cells are placed on top of that insert, and then they're put together like this. The primary competitor in this market is something called a Transwell assay. It's sold by Thermo Fisher Scientific. If any of you are in the sciences and familiar with that, I know we have a lot of business students, so just ignore this part. So there's a lot of reasons why they aren't good enough. The problem being primarily that there are low amounts of cell material that are gathered. They're incredibly expensive per square centimeter of experimental area when you break it down unit by unit. And they do not work with conventional light microscopes, which is a problem for scientists across the world. So our patent pending technology developed by Lsu, which we've applied for a design patent for, solves all of those problems. It also utilizes various sizes to accommodate many different applications. It's modular and adaptable to all of those applications I mentioned previously. It's licensable from Lsu. And if you see right there, those pictures below are actually made with 3D printer by me myself in my lab using additive manufacturing, which is how we're currently fabricating these prototypes. I wasn't aware we could bring props. I should have brought some. They fit about in the palm of your hand or smaller. So our split culture solution, you can see me there in the hood, is essentially a ring that fits into a base that you then put a hydrogel membrane into. A hydrogel is just a gel that's more water than anything else. I think it's safe to eat, but I haven't tried. And then we place them in conventional petri dishes that are 10 centimeters across. So this enables us to have a much larger cell culturing area. We collect 10 times the amount of material as our competitors at 1/25 of the cost to manufacture, which is a huge difference in our cost of goods analysis. And we're compatible with all microscopes. So any type of microscope you have, this works with. Just to break down our unit economics a little bit, we're looking at margins of upwards of 93% on any of our potentially our available units, I should say, for purchase. So that includes the 10 centimeter, which I showed you, and the 3.5 centimeter, which was the smaller example. And all of these are based off of additive manufacturing price to manufacture, and not including injection molding, which would bring our cost of goods way far down just due to the economies of scale. So the immediate market for our product is mid-size and public laboratories, which is a $550 million domestic market annually, a $15 billion market globally. And just to give the idea of the number of experiments done, it encompasses about 3 football fields, LSU football field being my favorite, but any football field will do. Just a brief roadmap of where we expect our business to go in the next 3 years, looking at acquisition by that larger player, Thermo Fisher Scientific, because that's just how our industry works. And then our startup budget, this should be called a bootstrap budget because we've been doing competitions like this along the way to be able to afford to bring our product to market in a way that is purchasable and not just a research institution sort of situation. And if you have any questions, you can email me and be sure to follow us on Instagram at Split Culture LLC. Thank you so much. I'm open to questions now.
where are you currently getting your product manufactured? I know you said 3D printing, but...
Yes, I actually took personal interest in 3D printing when I was much younger, and it became relevant to our laboratory to do prototyping with 3D printing. So I personally manufacture them using 3D printers in our space.
You usually use PLA or PETG? What are you using for?
Currently we use PLA or we use ABS when we're looking to do injection molding. We actually want to use a reclaimable acetate-based plastic because they're becoming more popular, so that would be sort of our end game. But yeah, just thermoplastics.
You mentioned your target market is mainly research laboratories.
Yes.
Right? So how do you go to them?
See, it's an interesting industry because it's not like we can send out like a magazine ad, right? And they don't use apps and things like that. Primarily, it's been conferences and trade shows. There's a lot of national conferences that I've attended, including like the American Chemical Society Conference, American Institute of Chemical Engineering Conference that I've also attended. And presenting our work there has generated a lot of interest. And scientists love to talk. So they'll gossip with each other about the best way to do something. And that so far has been what's brought in the most interest for our product. So,
have you actually sold the product?
We aren't able to currently sell it because we're still working on a licensing agreement. So any units that have been transferred to other universities have been through material transfer agreements. We're working on separating the IP that they own into our own LLC and be able to manufacture separately.
If I remember correctly, that slide, your retail price is $35, your cost is $245, something like that, or 93%
Yes.
gross margin.
Mm-hmm.
How does that $35 and the $350 for 10, how does that compare to the thermo?
Oh, it's roughly, I would say that price right there is based off an 85% of the Thermo Fisher Scientific. The reason why that pricing is so close to the pricing of our competitor is because our value proposition, the increased functionality of being able to see what you're doing with the light microscope and actually collect the material in a way that's utilizable for many different types of cells means that our value proposition outpaces that of our competitor, so we're expecting to be able to sell close to the same price.
Right. But so your price is lower, even though you think you've got a superior product?
Just a hair lower, and that's primarily because it didn't feel ethical to charge them way more to start with, but we're looking at pricing those units pretty close. Especially, and the lower price too is primarily to boost adoption early on, right? People are going to want to try something for a little bit cheaper, so that's sort of our entry to market strategy too.
And did I hear you correctly that your exit strategy is to sell?
Yes, absolutely. That's the way our industry works. It's very difficult. There are titans in the industry, so Corningware, Thermo Fisher Scientific, and what they do is they don't necessarily adopt a wholesale model. They won't buy from small manufacturers. If they see something and you're able to prove your concept, they're much more likely to buy the patent outright or buy your facility and your manufacturing style outright and then integrate it into their larger portfolios.
It sounds like you're set on selling to a strategic. Have you thought about private equity or venture capital?
We've thought about it, and I've actually gotten some offers in that space, but they didn't have strategic partnerships that were in this research area. If I were to come across someone who actually had those types of partnerships to build this into something that would be much larger and maybe not an acquisition exit point, that would be a great opportunity, but it just hasn't been something that I've been able to access yet.
You go back to the slide with the your 3D printed inside the feature disk.
Okay.
So they're having to provide the feature disk themselves, right?
Yes, but that's an expense that they would be providing with their an expense that's the same as if they would be using a different product, the competitive product.
So
as
the
well.
thermo product, you still have to use your own dishes.
Yes.
So this is the okay.
Yeah, absolutely the same. I say we are our own buyer, right? I do this research. This is my day job, and we buy petri dishes to use with all sorts of different things, not just with this. So they're not a one-use thing.
And your device is the blue
the blue
circle
ring.
and the cap.
Yes.
So
Yes. Yeah. So there's the base, and then there's the ring that goes around it. Yes. Yeah, it's a relatively elegant solution too.
The startups that you Bob Miller said you built 7 different startups.
Yes.
Were they in the same industry or completely different?
They were in different industries, but they all also included intellectual property that was related to hardware. So that's part of the reason why his experience is relevant. Additionally, those startups all were either acquired or made it to IPO. So he's providing advice on that sort of pipeline for us.
Who's currently funding you?
We've currently been funded so far by the LSU. I don't want to say Louisiana State University, the LSU Venture Challenge. So I won $10,000 with that last year, and that so far has funded us to date. But we are quite literally bootstrapping this so far with small amounts of grant money.
It's 5 minutes for questions.
Thank you so much.